Now, first thing what we're going to do is we're going to show you what's happening on the vSphere side. And I know it's a little fuzzy, the text is a little blurry, but ultimately in this case we have 3 clusters. We have a management cluster, an edge cluster, as well as a compute cluster. Now, your design differs based on what your requirements are, how big your environment is, right? In some cases, you might do a collapsed management and edge cluster. That's also perfectly fine. If you have a larger environment that's very dynamic, then you may want to have discrete edge clusters. Now, within the management cluster, this is where all your OpenStack components are going to sit, vCenter, infrastructure dependencies, right? Anything that's performing a management function. If we go over to the edge cluster, you can see here that we have an edge resource pool, right? So the edge pool is a new construct. It's created by the plugin, and it's really there to have a pool of backup edges that the plugin can leverage to quickly spin up services such as DHCP and logical routing. Let's switch over to the networking side. So here we have a single vSphere distributed switch, right? This plugin actually supports multiple VDSs, so you might have a VDS specific to management. You also might have a VDS specific to your compute layer. For simplicity, in our demo environment, we have a single VDS. And then here we've got an external network. This represents the network that provides outbound connectivity. We also have a management network. Now what we're going to do is we're going to go ahead and start up our Neutron service. All right, so we'll go ahead and type service Neutron server start. I'm sure Peter's done this a million times. And then we'll also tail the log, the Neutron server logs, so that we can kind of see what's going on. It's pretty blurry. So what you can see here is that there's a bunch of activity. The plugin initiates and instantiates the edge pool, right? It's spinning up a bunch of edges. These will be backup edges until we start actually consuming them through OpenStack. Now, the other thing to remember is that the edge pool is actually configurable, right? So there's a parameter within the configuration file where you can specify, how big do I want my edge pool to be. Okay. Now, the other thing that we're doing is we're also spinning up a VXLAN network that's going to be used for the metadata service. We're also spinning up these proxy edges, right? So the point of the proxy edges is to basically inject headers into the metadata request from the instance so that the controller and the metadata service can identify which instance this came from as well as which edge it came from. All right, so we have our metadata proxy edges. They're spinning up. The service is about to be started, right? Binding to port 9696, which is great. Now what we want to do is we want to look at what's happening on the NSX side. Right, so we'll go ahead and log into the vSphere web client. Obviously, we sped that up because it's not that quick. And then
hey, Ben, real quick, can I ask you a question? So I saw VIO. Do we need to have VIO for this?
Good question. So VIO is obviously it's VMware Integrated OpenStack. That's VMware's distribution of OpenStack. The beauty of that is the Neutron plugin for NSX comes bundled within VIO. So it simplifies a lot of the deployment, but it's not a requirement. Right? Our plugins are open source. They're available upstream. If you want to integrate it with a different distribution, we can also do that. Here we have a single NSX manager. We also have a controller deployed. That's going to help with VXLAN as well as distributed routing. From a host preparation side, we've prepared both the compute as well as the edge clusters for VXLAN. We also have a transport zone. Right? So a transport zone defines the boundary of your VXLAN. Right? So here we have a transport zone, and the transport zone has your compute as well as your edge clusters included. From a logical switching perspective, there's nothing there except for that metadata network that we created. And then from an edge perspective, we have, let's go to edge. We have a set of backup edges, right, as well as the metadata proxy edges. So everything is very clean. We just started the Neutron service for the first time. And then let's look at the distributed firewall rules. So the plugin will create a OpenStack cluster security group section. This is for kind of the global OpenStack configuration. There's also a default security group section here that is mapped to the default security group for the administrator tenant. So we'll go through a variety of exercises, and you guys can see how this is actually changing within NSX. All right, so we'll go ahead and log into OpenStack, right? So we're logging in as a tenant, right? We're logging in as the demo user. And let's take a look at the networks that we have. Right, so currently we don't have any networks because we just started the service. We don't have any provider networks, any tenant networks. So what we're going to do now as the admin is we're going to do a neutron net create, and we're going to create an external network that our user can leverage. So we'll do net create, corp net. We'll make it shared so that all tenants can use it. And we do --router external. So after that gets executed, you can see that from the tenant side, I immediately see that there's a new network available to me. This is the corp net external network. I can start plugging routers into that network. Next, what we're going to do is we're going to associate a subnet with the external network, right? And what this does is it gives us a pool of IP addresses that we can leverage for floating IPs. So now that I have my external network, I have my subnet associated to that. As a user, I want to create my own logical network. Right, so we'll go here, we'll create a new network, call it demo net, and then we'll go to subnet, and we'll put in any particular subnet we want. Right? The beauty of this is that as a tenant, I can put in any subnet. It doesn't have to be specific to something on the outside. Right? So we use a private subnet. We'll go ahead and kick that off. And then you can see that from the vSphere client, what it's doing is it's actually creating a DHCP edge that is responsible for DHCP on that particular subnet.
Hey, Ben, how does the DHCP scale? I mean, VMs, can only have 8 interfaces or something?
Right, so traditionally, an edge can only connect to kind of 10 interfaces. Right. But there's a new feature within NSX called sub-interfaces. Right? So you can define additional interfaces on a single interface. So we can actually have up to 200 sub-interfaces per interface. So that's a great question, because the way that the implementation works is that NSX will create a port group called the edge port group, and then it will wire the DHCP edge to a VXLAN trunk port. Right? So this DHCP node can actually service multiple networks, right, across multiple tenants. All right, so now we have our network created. You can see it there. We've got an external network as well as a tenant network. So the next thing we're going to logically do is we're going to go to Nova. We're going to spin up a couple instances and wire those to our tenant network. So let's go ahead. We'll put in an instance name. Let's put in 2 for the instance count. We'll choose our image. Right? From a security group standpoint, right, we use the default security group, and then we'll connect it to our tenant network. Now what that does is Nova will start to initiate the process of reaching the vCenter, deploying the virtual machine. It'll talk to Neutron and say, wire these 2 instances to the logical network that I specified. And then if we go back to the DHCP edge that we spun up, you can see here that there are 2 static bindings created on the DHCP edge, and those correspond to the IP addresses that we gave out for those 2 instances. All right, so these are spawning. Now they're active. So let's go ahead and click on one of the instances. All right, so the logical next step is let's test connectivity between these 2 instances that we just spun up. All right, we'll go ahead and log in to the instance, do an ifconfig. Right, so this confirms that we received an IP address from the DHCP server, which is sitting on the edge cluster. Next, we're going to ping the instance, the other instance that we spun up. And you can see that we have connectivity to the other instance. The great thing is that with network virtualization, it doesn't really matter where your instances are sitting, right? As long as your hosts have like layer 3 connectivity, the instances can be sitting anywhere in your data center. But with logical switching, it looks like they're layer 2 adjacent. The next thing we want to do is we want to ping an external device. So we're going to ping 8.8.8.8. And you can see here that we don't have connectivity. Right? Jonathan, why don't we have connectivity?
It's probably because it's not connected to the external network.
Right, right. So if we go back to our network topology, right, you can see that we have our instances, but they're separated. There's no connection to our external network.
I really had no idea, by the way.
I totally put them on the spot right there. Sorry about
But yeah,
that.
I mean, there's no router to the external network.
Right,
That's
exactly.
usually the problem. When a developer says, I can't connect to the internet, it's like, did you create the router to connect to the external network? And that's an education thing, right? It's just making sure the end user knows that just because his VM is on a network, it doesn't mean he's automatically connected to the internet. Yeah, or anything. Yeah.
As a tenant, again, the beauty is that the tenant has the ability to create their own logical routers. So here, I've created a demo router, and then I've specified the external network as CorpNet, right, as the gateway for that particular router. We'll go ahead and spin up the logical router. Right, you can see that on the vSphere side, it will reconfigure an edge device to be the logical router, and then map the gateway appropriately. The next thing that we need to do is we need to point back to our logical network that we created. If we click on interfaces and we add an interface, right, choose our logical network, DemoNet, and execute that, the plugin will go ahead and wire that particular logical router interface onto the virtual network that we created. If we click back on our tenant network, might be a little bit hard to see, but you can see that as far as the various ports that are associated with that logical network, we have the 2 instances, we have our DHCP, we also have this router interface. And then just to verify, we'll go back to network topology. You can see that now we have a logical router. It's connected the tenant network with our external network. Let's go back to our instance that we were trying to access the external interface from. So we'll go ahead, rerun the ping command, and you can see that now we have connectivity to the outside world. The next logical step is, okay, I have access from the inside to the outside. How do I provide access from the outside back into the instance, right? And that's done through floating IPs. So what we just did is we created a floating IP. We had a subnet that was on the external network. So we allocated a floating IP from that pool. And then what we can do is we can associate that floating IP to the instance that we want to connect to. Right, so we'll go ahead and we'll select the instance, click associate, and what the plugin does is it then creates NAT rules that specifies, here's my floating IP, allow access back into this particular instance with a private IP address.
Yeah. So the network admin, they create a pool of floating IPs that are routable, and then the tenants can consume these floating IPs depending on what his or her needs are internally. And like Ben said, they're natted so that if you're running a web server, a node on the internet can access the instance within this tenant network.
All right. Okay, so let's go ahead and, on my desktop, what I want to do is I want to ping the floating IP. So we can see that it goes through. That means I have ICMP between the outside world and back into the instance. The next thing I want to do is I want to SSH into that particular instance, right? And you can see here it's not working. Why is it not working, John?
Firewall rule. It's got to be a firewall rule.
Okay, so security groups, right? Security groups are a construct in OpenStack it's an overloaded term. There are also security groups within NSX as well. But if we look at the default security group that's applied to every single instance that gets spun up, there's no specific rule allowing SSH. Right, so as a user, I have the ability to go in, create a new security group, and let's call this allow SSH. Right, so again, this is an OpenStack construct. It's not doing anything on the vSphere or NSX side. But next, what I want to do is I want to add a particular rule that allows SSH into my instance. Now, what this does on the NSX side is it will trigger the creation of a security group section in the distributed firewall, right? So now I have a security group section called allowed SSH. And then if we expand that, we can see that it's got the SSH rule created. It also created an NSX security group. And then the second that we actually associate the allow SSH security group back to our instance, let's go ahead and do that. Right, so now we've added that instance into this particular security group. If we do a refresh, we can see that now that VM is part of this NSX security group, which is bound by this particular rule set. Right, so now we have SSH connectivity. We're able to log in, and we have access from the outside world back into our instance. And again, all this is configurable by the tenant. Right? This is not something that your admin has to facilitate. So that might have been pretty tedious. You know, Jonathan, maybe I thought it was pretty cool. Maybe you didn't think it was cool enough. Right, so next what we're going to do is we're going to show you the automated deployment of a very complex topology. So this is leveraging the Heat project within OpenStack. Right? Heat is the orchestration project. And what this allows us to do is it allows us to define a set of OpenStack elements and wire them together in a single unit of deployment. Right? So we have a Heat creation wizard here. What we're going to do is we're going to paste in a JSON file. Right? So we have a fairly long JSON file. It's got a bunch of definitions. Let's go ahead and name the stack. And then we'll launch that particular Heat stack.
We got 10 minutes.
Yeah. Okay. Now what you see here is that it'll launch a bunch of different elements on the vSphere side. Right? So it's creating a bunch of different things. The great thing about the Heat template is that it looks at all the things that you're trying to create, and then it knows what the correct order to start creating all the various elements are. Right? So there's a lot of different things going on here. That we have load balancing as a service, right, which creates a load balancer, a monitor, pool members. We've got multiple networks here. We've got multiple instances. It's wiring them all together using logical routing. So again, the benefit here is your developers, they can start formulating what type of application do I really want, right? How is that wired up? They can standardize on a particular Heat template, and then everybody can start deploying them very consistently. Okay, so basically the Heat template, it takes a little bit of time to generate. So we sort of sped up the video a little bit due to time. Now everything's wired up and complete, right? Everything is, you can see that all the elements have been created. If we go back to the overview as well as the events, we can see that everything was created successfully. Now we can actually go back into each individual project. We can see that all the elements specified in our Heat template were created. Right? Then from a load balancing perspective, we've created a load balancer pool. We have a specific monitor. We specified members. And then to wrap everything up from a network topology standpoint, if we take a look at this, let's shrink it down a little bit.
So just imagine for a second, if one of your developers or end users wanted to create something like that, how long would that take without network virtualization? It might take weeks or months, right? So the flexibility here is, within an instant, your developers get what they need and they can go about doing their business.
Exactly, right. So with a simple click of a button, right, it may take a bit of time to develop your heat template, but once it's created, it's standardized, anybody can leverage it. And here we've created a multi-tiered application with routing in between. We've got load balancer as a service, and we're able to deploy that very quickly.